Hello everyone, and welcome to today's webinar on the Geographic Calculator for the month of February. Currently, all attendees are in listen-only mode, and you should be able to see the first slide on your screen. I'm Heather Poirier, Marketing Manager for Blue Marble Geographics, and I'm here today with Sam Knight, the Director of Product Management.
Good afternoon, everyone. So today's topic that Heather and I are going to be talking about is custom parameters in the Geographic Calculator. So the types of data we're going to be dealing with are fairly limited, actually. We usually throw up some different types of data files, but today the data is actually parameters. So we're going to be talking a little bit theoretically. We're going to be stepping through how to generate parameters in the calculator job. The example we're going to be walking through is creation of a custom projection, in addition to that into the custom database. We're going to be doing that. We're going to be spending most of our time in the data source menu and the dialogues that are associated with that for working with customized projections, and we're going to take a quick example of that on the interactive conversions job. Really what we can do with the custom parameters is going to be something you can apply on any of the interfaces throughout all of the Geographic Calculator. We're just going to take a quick example of it on the interactive job.
So we have some light housekeeping to address first. If you have any questions during the presentation, you can use the questions tool on the GoToWebinar panel to the right of your screen. We will try to answer all your questions as they are submitted, but the presenter will also take some time to address all your questions at the end of the presentation.
And if we don't have time for a given question during the session, if we do run out of time, you can always send in an email to our support team. And the email address is right at the bottom of your screen there, geohelp@bluemarblegeo.com. You can send in a question there at any time and have someone on our tech support team get back to you. And we've also got some upcoming conferences and events and trainings.
Yeah, on February 13th, we're going to be at the Illinois Professional Land Surveyors Association Conference in Springfield. We also will be at the International LiDAR Mapping Forum on February 17th and at ERISA on February 24th. And we also want to point out that we've currently updated all of our training events, so you should visit our website and check out any additional training if you're interested.
Okay, and in particular, I know at the ILMF next week, Chris Berglund, who's on our sales staff, is going to be giving a presentation there on terrain analysis. So that should be pretty interesting for anybody in the area. So definitely go ahead and check that out. And what we're going to start off with here is we're going to jump right over into the Geographic Calculator. And before we really get things rolling, I just want to start a quick poll today. I want to see who's with us. On your screen, you should see a poll coming up. How long have you been using the Geographic Calculator? Whether you're just getting started or whether you have a little bit of experience or whether you've been with us since the beginning. We have been around over 20 years now. 2013 was our 20th year, so we've actually got some folks who've been using our stuff for more than 20 years, and it looks like we've actually got somebody on the line who's been with us that whole time, so that's great. Looks like we have a lot of new users. I'm just going to leave this open for another second. Looks like the responses are starting to slow down here. So it looks like we've got a pretty heavy new user contingent. And folks with at least a few years of experience, so a good mix today. I'm gonna just close that up. I'll share it out so you can see what we have here for attendees. So about 75% of us are just getting rolling with the application, so that's pretty cool. And those longtime users in there as well. We always say it's very possible to learn something new every day here at Blue Marble within the calculator. There's always something for everybody. So. Hopefully you'll pick up something that maybe you didn't know before. And so I'm going to take that away, and here we are in the Geographic Calculator. Now, the interfaces we're going to be taking a look at today. We're going to be coming back here to the interactive job that we're on right now. For those of you who are just starting out, with the calculator, the interactive conversions job is where we set up individual point conversions. So on there's going to be some standard controls on the interface. At the top of each interface, whether it's the interactive job here or some of the other job types, things like point databases, seismic data, vector data, the interfaces on these are fairly standardized. At the top of the interface is where you put in your data. Somewhere, sometimes it's in the middle, sometimes it's at the bottom. You're going to see these coordinate system boxes for defining our input, which is typically going to be on the left. It's not always on the left. Our output, which is typically going to be on the right, but not always on the right. And the coordinate transformation, where you're going to do things like select a datum shift or some type of parameters to link up those two coordinate systems for transformation in the middle. So what we're specifically going to be taking a look at today is the parameters themselves under the hood. So we're going to be taking a look at defining a new coordinate system, and we're going to set that up for a little bit of a test once we've applied that. So with the interface that we're looking at here, the interactive job, this is going to be where we take a look at our quick example, but again, the custom parameters that we're going to be taking a look at are something that apply all throughout the application. We're going to start out looking just on the sort of the end use of them. So on an interface here, I'm going to start in here as if I were going in to select a coordinate system. So I'm going to double click, and up comes this dialog. And this is a dialog we added in the 2013 release. So if anybody's on an older version, this isn't going to be a dialog you see on the way. This is a dialog that offers you the chance to select a coordinate system or a set of parameters using a map interface. So you actually click on the map in the part of the world. For this example, I'm just going to say no. I just want to get right into our main database here. And in the dialogues that we've got, we're going to be working in dialogues that look a lot like this. But there are two modes to these dialogues. There's the selection mode that we're in right now. What we're going to be doing is going under the data source, the edit mode, under the data source menu. So at the top of the screen, you're going to see two paths in there. Those are paths to the given data sources that are used inside the application. I'm going to get back to that in just a second. The folder list on the right, on the left, is the way we structure the organization of all of those coordinate systems, the datum shifts, the linear units, angular units, all of the stuff that's in the databases. And on the right is the details panel, where we actually show the individual names and some of the other data that we can see in the columns in the main panel on the right there. Now, all told, there's about 5,000 different coordinate systems out of the box in the stock database. Now, the stock database is this file at the very top called geodata.xml. We synchronize that with the EPSG database. If anybody's familiar with that source, the EPSG database is essentially the de facto standard right now in the world for standardization of coordinate system definitions. So from that we get, we throw this number around 5,000. It's actually somewhere over 5,000 by now, but there's somewhere in the neighborhood of 5,000 coordinate systems available at your fingertips. But sometimes that's just not enough. If you have a particular cartographic application, if you have a particular business case in your company, you may have the need for custom parameters. That's where the secondary file comes in. This custom data source shows you the file path there, ends in custom.xml. That is where all of your definitions are going to go. And those might be your personal definitions, or those might be shared definitions if you're one of our users who's on, say, a large network installation where you're actually sharing common databases with other folks at your company. Where we're going to be working today is in the custom XML. And the funny thing about that file is it doesn't actually exist out of the box. It is just a sort of a placeholder. It's where your stuff is going to go when we create it. So if you go looking for that file path that you see listed right at the top, it may not actually exist if you don't have any custom parameters associated. What we're going to do is actually go ahead and create one of those today. The dialogues we're going to be working in here, I mentioned they look very similar to this, and it's actually a different mode of the same dialogues. And it's a mode that allows us write access to the custom XML. Now, within the dialogues here, we've got two database files that are actually displayed together. We don't actually see that out of the box because there are no custom parameters until you actually go ahead and create them. So right now, all I have are entries from my stock data source, my Geodata XML. You'll see all of these entries in black text, and you'll notice this little padlock icon displayed next to each of them. The padlock indicates that it is a locked and protected coordinate system, and out of the box, all of these stock definitions are locked up and protected. You can't actually edit the parameters of them. You can't delete them. You can do things like hide them or organize them into different folders, but you can't actually harm the parameters themselves. What we're going to take a look at here is making copies of those and editing those copies, and also just plain starting from scratch with a completely new coordinate system. So to do that, we're going to need to leave this view and go under the data source menu. So I'm just going to back out of that dialog. Now over on the top left is where we have all our normal menus. The data source menu is where we go to get into any of those individual parameters. There's really two pieces to the data source menu. There's the top section and there's the bottom section. You'll see a little divider line down here almost all the way down at the bottom. The top section that goes from linear units all the way down here to vertical reference definitions are where we get in to actually modify any one particular type of parameters. The bottom half we're going to come back to a little bit later, and this is where we can import or export coordinate systems or transformations from a number of different places en masse, or to bring those in directly from files. Where we're going to start is up here in the top section. And so the example I'm going to walk us through here is going to be creation of a custom projected coordinate system. It's a fairly similar process if we're going to be adding things like custom transformations, custom linear units. The idea is going to be pretty much the same, but what we're going to take a look at is adding a new projected coordinate system and testing that. So I'm going to go in under coordinate system definitions, and I'm just simply going to click on that, and it's going to pop open my edit data source dialog, and in the folder list on the left hand side there you'll see I'm specifically looking at coordinate systems. Now if you're looking at transformations or other types of parameters, you're going to see different categories on the left hand side. Some of these items are going to be organized into folders, and other categories where there aren't that many objects, things like linear units or angular units, you're just going to see one single folder containing all of the objects in there. Objects is a term that we use. It's a database term. Basically, every individual coordinate system or every individual unit is an object in the database. So where we're going to start off here is in down in the folder section for the area that we're working. So I'm going to be working on a projected coordinate system. And so if we expand that list, you'll see that we already have some folders down here. So our folders out of the box are basically geopolitical. So first they start out at the continent level, and then they go down into smaller regional subunits. So where I enter mine, very commonly, I just simply enter mine at that very top level in the projected category. Other folks like to have a dedicated folder that gives you a little more clear place to click on for some folks. Some folks like to create several folders. There are a number of ways to place this in here. What I'm going to do is I'm actually going to create myself a new folder in here, since that's something a lot of folks do like to do. So I'm going to just simply either right-click on Projected and select New Folder, or if you click this little plus button underneath, it's going to add a new folder in there. So you'll see a new blank folder come in, and it's simply going to be called New Folder. Now, if we want to rename that, all you have to do is just simply click on it. And so I'm going to call this Sam's folder. And the name does not really particularly matter in here. You have total freedom over that name. Some folks like to put in the name of their company for wherever you happen to be. So, it might be Blue Marble Proprietary Coordinate Systems. They can be long names. They can be short names. It doesn't really matter. It's just a name of a folder, just like you might stick files in on your machine. As soon as you click off of that and set the name, or if you hit enter and set the name, whatever you've entered for the name, it will automatically re-alphabetize itself. So you might have just noticed that my folder jumped down in the list when I called it Sam's folder. From there, it acts like any other folder. And the folders themselves get stored in what we call the view file, which is another configuration file here that actually merges both of the data sources for us. And I'll come back to that view file a little bit later on. So I've added my folder, and now I'm ready to create a coordinate system in it. So I just want to make sure it's still selected. If you've accidentally clicked on something else, you want to make sure you go back and have that folder selected. And in the right-hand panel, it's the same thing as creating a folder. I can hit New Object over here, the little addition button that we'll see underneath the Details pane, or I can just right-click in there and say New Object. And this is going to open up a projected coordinate system editor. And this is going to appear a little bit different depending on whatever type of parameters you're trying to add to the database. If you're adding a transformation, you're going to see one set of things on the definition. If you're adding projections, you're going to see one set of things, and so on. They do all have some similar elements. And those elements are namely the two tabs here that you'll see. There is an identification tab and there is a definition tab. On the identification tab, this is where we're going to be entering things like the name of this system. So we can give that whatever name we want to have appear in the list. And from this example, I'm actually going to be creating a fictitious projection that I've just made up that's centered on the North Atlantic. It's an area where it doesn't really have a whole lot of coordinate systems dedicated to its whole area. So I'm going to create myself a North Atlantic projection in here. So I'm just going to call it that, and I'm just going to punch in the name there, North Atlantic map projection. And in the remarks, this is an area where you can add a description, or you can add some information on the source of the parameters that you're working with. At some companies, folks will come up with some business rules for the type of remarks that will be put in there, things like the date added, or the source, or on whose authority it was added in there. It's a completely optional field, but it is always a good idea to put some kind of information in there. If you're working by yourself, you can leave yourself some notes on the coordinate system. For my example here, the projection that I've created is really going to be more for cartographic use only. So I might leave myself a little note in here that says that. I might just simply add a little tag in here that says cartographic use only. Some folks will add in notes that say not for geodetic use specifically, or they might put information on the appropriate map scale of use in there. But the remarks, again, totally up to you. Down under the identifiers, this can be useful to you if you are sort of trying to link up parameters across multiple databases. If you have gotten the parameters from a particular source and you want to track that source, particularly folks at large companies find this more useful. You'll see what's called a GC code in there, and it's a long kind of gobbledygook sort of number. That's an automatically generated code. It doesn't really mean anything to the end user. We just simply use it for indexing inside the database. GC stands for Geocalc, which is our own engine that powers this under the hood. If you have done something like gotten parameters from the EPSG database, say in between releases, you might add in a new identifier, and it's as simple as saying insert tag, and then you type in the name of the identifier. If it's from the EPSG, you would just put in EPSG. We have a number of standardized codes that we punch in there for the who issued that particular code. So you might see things in other definitions that are stock definitions that come from the EPSG or that come from, say, Oracle spatial databases, things like that. You are also entirely free to enter your own if you have your own proprietary database. So if you are the admin and you're merging over transformation support from maybe an older in-house software, you can actually put in your own codes, and then folks can use those to actually look up your internal proprietary definitions. If you don't have any sort of structure like that, you can just move right past the identifiers. You don't need to do anything with it. In particular, if you are maintaining a lot of custom definitions, down at the bottom you'll see a deprecated checkbox. And the deprecated checkbox is what you do with a coordinate system or any type of parameters for that matter that are no longer considered valid for use. So say, for example, in your company you've found that there's been a custom projection in use for a while and it is erroneous in its definition. There's got bad parameters or outmoded models, something like that. It's not always a good idea to delete those in case you ever need to use it again to take some old work and undo it, basically to reproject out of a bad coordinate system. What you can do instead is tick off the deprecated checkbox, and it will automatically enter in today's date. You can put in whatever date you need, and that will leave that in place in your coordinate systems list. It hides it automatically by default, but it actually leaves it in place in the database so that you can unlock that again. If you're an admin user, if you've got edit control over your database, you can always go back and wake that system back up if you ever need to use it again in the future to undo some bad calculations or things like that. I'm creating a new coordinate system. It's one I want to use, so I'm not going to toggle that deprecated switch right now. And really those are the main things on the identification tab. What you might see extra is if you're adding in a coordinate transformation, you'll actually see another box in between remarks and identifiers. That's a place where you can enter in the accuracy rating for a particular transformation. That's another pretty useful piece of information. Then over on the definition tab, this is really what we call the meat and potatoes of a set of parameters. So this is where, for the case of the projection I'm going to be creating, a new projected map coordinate system, this is where I'm going to fill out all of the standardized components that I have. Now this also is going to appear different depending on what type of projection you're dealing with. Very common components for a coordinate system are at the top here. So there's an envelope, or that's also known as an area of use, that tells us where the particular definition is found on the planet, where it's applicable. There is a point style that we'll see on there. That is essentially the type of units that are used with the system, but it's a little more than just units, and I'll show what that is as we're filling that out. The geodetic model, that is most commonly known as the datum that the system is going to be based on. And then there's the projection. And the projection controls everything else we see at the bottom of the interface there. We're going to be defining a conic projection, so we're going to see that change in just a few minutes. Now, the definitions themselves at the very top, sort of the main things here. We start off with the envelope, and all new definitions default to a world area of use. So you don't have to change that if you don't want to, but it is very useful for reference. Some folks will find adding in more specific envelopes, they'll find that overkill, and other folks will find it to be a very useful tool depending on how many custom systems you're going to be dealing with. What this does is it allows us to define exactly where on the planet a particular coordinate system or a particular transformation is valid. So in the list that we have to choose from, we have a number of areas of use here that we can define for the projection we're dealing with. If you actually want to create a custom envelope, you can also do that. So all of these are just simply stock definitions. There's nothing particularly special about them. They just simply define where on the planet a particular system is useful. Now, for the area that I'm working with, It happens to be a pretty large area, so it's going to cover basically the entire North American, the entire North Atlantic Ocean area. So I could come down through here the list and find one that's applicable. I could simply pick the Northern Hemisphere. That would narrow me down a little bit. In this case, it's the entire Northern Hemisphere, when really I probably need a slightly smaller envelope than that to cover just the Atlantic. Again, if I wanted to, I could create a custom envelope and assign that. For now, I'm just going to pick the world Northern Hemisphere and leave it a little bit on the loose side. Now I select that, you'll see it updates in our main envelope. You can always go back to browse for a new one or see the parameters of the envelope that you've selected by clicking the two buttons there on the right of the picker box. The point style right below that, I mentioned this was linear units or angular units and a little bit more. Let's get into that and we can see what the point style is all about. So in the point style, you'll see a number of things that have kind of complicated sounding names. You'll see things that are Cartesian two-dimensional coordinate system. You'll see things that are projected point in a certain unit. Let's go down and take a look at the one we're actually going to use here. We're going to use a projected point in meters. What I'm going to do is I'm just going to right-click on that and view its information. This will show us the parameters of what makes this a thing. So a point style, I mentioned, is the units that we're going to use, but it's a little bit more. And the little bit more part of that are the labels that we're going to be applying to the coordinates in the system. So in this case, I have a projected point style that is a three-dimensional type of coordinate, possibly. I'm going to be calling my east-west axis there my easting. I'm going to be calling my north-south axis my northing. Depending on the coordinate system that you're using, those could actually go in different directions. We might have southings and westings in some very particular parts of the world. The height values might be called orthometric heights in some. They might be called gravity-related heights in another. All of these different labels are the extra pieces that come along with what we call the point style. So really the easiest way to think about that is the units that we're going to be using, but it's really units and the label definitions for the axes of those coordinate systems. So what I'm going to do here is grab onto my projected point in meters. So we're going to be working with metric coordinates in our projection. And for my large area here, the geodetic model, I'm going to put this onto a very common model used in the world right now. I'm going to put this onto a WGS84 coordinate system, sort of the current GPS standard. So this is basically the geographic coordinate system that goes along with the horizontal datum that your coordinate system is going to be using. Now, all of these pieces that I've been picking own their definitions on their own in the data source. So if you need to be working with a custom geodetic model, obviously before you apply that into a projection, you would need to go and define that custom geodetic. So either maybe you need to create a horizontal datum, maybe you're actually even starting all the way down at the ellipsoid definition. Any of those pieces that are going to stack up into a coordinate system need to be there first. So it's possible to add any and all of these into the database. It's just a matter of how high up you're going to start with that definition. Mine is, in this case, going to be made of pieces that already exist. So I can just grab onto the WGS84 datum, and I can grab right onto projected point in meters. What we find is that most users' custom parameters are going to be made up of some combination of things that already exist. It's a fairly rare case now with all of the coordinate systems that come out of the box that you've actually got to go all the way down to the bottom and create a new ellipsoid or things like that. But you can if you need to. That's the point I'm trying to get at here. Now for the projected part of the coordinate system, this is where we simply see a drop-down. So the drop-down menu lists off, there's somewhere north of 90 different types of projections that are available. Each of these has slightly different parameters. The one I'm going to be working with here today is called a Lambert conformal conic. Some people might know that as Lambert two-standard parallel. You'll see some variations there. Some of these do have different variations. If you're curious about any of these, you can simply just click on them to see what the parameters are. But you can also find these, there's a whole section on the projections that are available within the application. There's a whole section of this defined in the documentation with the application, and it tells you what each of the parameters are that's required. It can give you a little more information about why one variation is used over another. If you're dealing with anything that's a little bit odd, you're not too familiar with it, you can always contact our support team. We're very familiar with a lot of the things that are considered slightly more unusual coordinate systems just because of the nature of the work we do here. So if you've ever got any questions about that, don't be shy with the support team. So the projection that I have, this happens to be one that I've made up, but very commonly you might be given a printout with some parameters on it, and it's simply a matter of transposing all of the various parameters that you've got written down into the applicable place in the projection parameters themselves. So as I change that to Lambert conformal conic, the parameters down bottom changed here to match the needed parameters for that. Some of these are going to be things like latitudes or meridians, such as our central meridian right here. Those will automatically default to an angular unit like degrees. Things that require a linear unit are going to automatically default to meters. But if you do need to change those, you just simply click the buttons and pick whatever type of units you're actually working with. It's not terribly uncommon to need to sometimes define things in a survey type unit, or in the case of some of the angles and such, they're very often defined in things like radians or microradians. So all of those units are available there on the right hand side. So I'm going to punch in the parameters that I've got for my new made-up coordinate system. So it's actually centered in the middle of the Atlantic Ocean. And the false easting and false northing are basically suited just to create us positive coordinates throughout the entire area of the North Atlantic Ocean. So I have a false easting of 5 million, and I have a false northing of 6 million. One more zero, there we go. And those parameters are essentially what keeps us in the positive quadrant of the Cartesian plane that we use for projected coordinate systems. Why we use those is sort of essentially just to make our numbers all positive. They're going to come from whatever your publication is. Sometimes you will see negative values entered in, and that's actually very unusual for most coordinate systems. Your false easting and false northing are almost always going to be positive values. The latitude of origin is almost always called latitude of origin. Sometimes you'll see central meridian appear with a different name. Both of those are basically the components that make our origin. Sometimes you'll see longitude of origin instead of central meridian. Those are standard and interchangeable words. So in this case, our latitude of origin is going to be 30 degrees north of the equator. And my standard parallels, where I'm going to have lines of true scale on the map, are going to be, in this case, I've got one at 15 degrees and one at 45 degrees. So this is just simply a matter of matching up all of the parameters from the definition I'm trying to bring in and filling them out in the projection. If you have a definition that you're given, you're trying to punch this in, and you have extra parameters, or if you have not enough parameters, there's a very good chance that you're not looking at quite the right projection. There are a number of projections that have different extra pieces. There are variants of projections. In the case of the one we're looking at right here, you'll notice there are actually, let's see here, 1, 2, 3, 4. There are 5 different types of Lambert conformal conic projection. They're all different variations of each other. They have some special uses. Lambert 27 in particular is a modified version of the projection that is used in old state plane coordinate systems here in the U.S. Lambert conformal conic extended, that's another one where the projection is actually used on, it has some extra scaling parameters that either raise or I should say inflate or deflate the ellipsoid surface that they're on. Lambert tangent is another version of this, sometimes also called Lambert 1 standard parallel. So all of these have very slightly different parameters, and you want to very, very carefully make sure that you are using the version you intend to be using. And again, if you ever have any questions about matching up specific parameters, let us know. It's the kind of thing we can usually answer very, very quickly, just because there are a lot of these, and we're familiar with working with some of the more edge cases. So I've filled out all of my parameters. I'm going to be pretty good to go here, so I'm going to say OK. And we're going to see that, that new coordinate system appear in my folder. And you're going to notice that I'm going to deselect there just so you can see what it looks like in its normal state. You're going to notice that there's no padlock icon next to that, and you're going to notice that the text is bright blue. Those things together indicate that it is going to be found in the custom database. So this is not a standard projection. This is going to be something that I have added in there myself. Maybe I've made a copy of something else, but this is going to be only found in my custom parameters, not out of the box. Now, just for a quick example, I'm going to toss another coordinate system in there by making a copy, just so we can see what happens. What I'm going to do is grab onto a common UTM zone that I work with all the time. So I happen to be located in the area of UTM zone 19. What I'm going to do here is I'm going to do a couple of things at once. What I'm going to do is grab onto that coordinate system, and I'm just simply going to drag it over to Sam's folder, and I'm going to let go. And when that is dropped onto Sam's folder, you're going to get this pop-up, and you're going to see you have an option to either move the coordinate system or to create a shortcut to that coordinate system. What I'm going to start with here is simply creating a shortcut. And when I do that, you're going to see I now have WGS84 UTM Zone 19 available. It is a stock coordinate system. It's still locked down, but I have a shortcut to that in my my own folder. Getting into the custom folders, some folks will use this as a way of making your own little favorites list. So it's possible to have both custom entities and stock entities in your own custom folders. You'll notice that I did have an option to actually move that UTM zone. So you'll notice it's in the original folder under the UTM group, and it is also now in my folder. It is the same thing. Basically, both of those point to a single definition found in the data source, but you can get to it from either place. So there's a lot of ways to use that, depending on if you just want to make yourself a quick favorites list, or if you are actually doing this on a large scale with a lot of other users, and you're trying to make yourself a quick folder of projections that are commonly used in your enterprise. Now, this is a stock definition. I can make a copy of it, and I can edit that if I wanted to make sort of a modified version of it, just simply by right-clicking on it, and you'll see an option there to copy the object. And what that's going to do is pop open a definition panel like we were just working with. It's going to automatically add copy of the original name there into the name. You can change that to whatever you like, and you're free to modify the definition however you like, because this is going to be a new creation. I'm not going to do anything to this one. I'm just going to go ahead and say OK, and then you will see your copied coordinate system show up in your folder. It's going to show up unlocked. It's going to show up blue, indicating that that is yours to modify or delete, do whatever you need to. And any of them work just like any other coordinate system in the database. So a lot of folks will actually start with a modified version of an existing coordinate system. A fairly common thing that some folks need to do is create what's called a half UTM zone, a UTM-like coordinate system that actually appears on the seam between two overlapping areas of use. So let's say I was working in between zone 18 and zone 19. I might make a zone called 18.5, and it would just simply be offset in between where those two fall. That's the fairly common thing a lot of folks do with custom projections. So now what I'm I just wanted to take a quick little tangent there. What I'm actually going to do now is validate that my coordinate system is appropriate, that I've made sure that I've actually put everything in as I've intended to. So what I'm going to do real quick here is just simply save that definition. And it's going to prompt me that I'm going to save that into the custom XML file. You do need to have write access to it, obviously, in order to be able to do this. So that is both admin level permissions within the calculator, but you also need to be able to physically write in Windows in the operating system. You need to have write access into the folder where that is stored. Those are the only two things that really get in folks' way here when you're trying to do that. I'm going to go ahead and say yes. It's saving my system in there, and then I can go and actually apply that system on any of the jobs that we've got in the calculator. So I'm just going to hop out here to create a new interactive conversion. We're going to see my new job dumps down in the list there, and I'm going to select my new coordinate system here. I'm not going to bother limiting it by area because I know right where to find it in my projected systems list. So I'm going to come down here, I'm going to find Sam's folder. There's all the systems I was just playing with. I'm going to grab onto my North Atlantic map projection, and we're going to say OK. So there's my system in there, functional just like any other system. And very often what's a very useful thing to do is if you're working with a new definition of any type, whether it's a transformation or a coordinate system, is to have some kind of a control point to check that off from. So if you're working with data from another software package, or if you've got a survey sheet, something like that, it's a very good idea to run a control point through just to make sure we're actually falling in the right part of the world. So I'm going to take a quick look at just how to do that. And in this case, I've got a particular coordinate that I'm going to validate. I'm just going to punch that in here in my interactive job. And we're going to make sure that I'm falling in the right part of the world. So I've got a little over 6 million in my northing, 6 million meters, and I've got about 3 million, let's see here, 3217. 960, and these numbers, these are numbers that I created before when I was testing this coordinate system on another installation. So I'm essentially just making up these numbers. Ideally, you're going to have some sort of a valid control point, and what I'm going to do is just sanity check that these fall into the right part of the world. I'm just going to double check that I've typed them in there. 6405, yep, looks everything good there, and I'm going to calculate these from one system to another. So in this case, I'm going to check this out against my WGS84 lat long, my default system. You can check this against whatever other system you need to. But one of the things we've built in here for a very useful little sanity check is a right-click option. Once you've got your output, if your output is in WGS 84 latitude longitude, you'll see a little right-click option in here to open the point in Google Earth. And so I'm going to click on this, and I'm going to cross my fingers that my internet connection is okay and that Google Earth is up and running. It's always a scary thing to rely on some third-party software in a live demo here, but it looks like it's working just fine for us. And
so Sam, while that's going, if I can interrupt you, how many custom systems can people create?
There's no limit on that. If you want to sit there and import or manually define thousands of custom systems, there's absolutely no limitations on how many of these things that can come in. So it's totally wide open. There are some folks that I've worked with that I know have literally hundreds of custom coordinate systems, and there are some folks that only have the one extra system they need. So it's really quite flexible in that sense. That's a good question. Thanks for asking, Heather.
Not a problem.
So we've landed in at our point there. We've added in a new point. You'll see it comes up saying unnamed, and I neglected to enter in a name there in Calculator. If I'd punched in a name for my point, I would have a nice little label there in Google Earth. And so in this case, the point I had intended to land us right here on this beach on Surf Bay in Bermuda. It's a place I'd rather be here today. It was -5 when we woke up at Blue Marble this morning, and it's probably a little bit nicer down in Bermuda there today in Surf Bay. So my control point has come out where I was expecting it to be. I'm now fairly confident that that coordinate system is accurately input. We can check many other types of data if we like. If we have, say, some vector files or some point database files with multiple control points, the more checking the better on any customized parameters. Whether you've entered in a transformation or a projection, it's always a good idea to make that quick control check. And from there, it really comes along to sharing those with other users. So gets down to the bottom half of the data source menu. So there are a number of other import methods here that we can take a quick look at. There are options to import parameters from the EPSG registry. This opens up a dialog similar to the dialog that we use to browse all of the definitions. And this live connects to the EPSG's main servers. They're hosted in London over in the UK. This tells us all of the particular entities of a type, whether it's ellipsoids or datum transformations, any of those things. This will pull down all of the current definitions for a particular type. From there, we can simply import an object if it's something that does not already appear in our list. You'll see there's a column on whether or not a particular definition is already found in your local database. If something is not found in the database, you can import that, and it is treated like a custom object until we do our next synchronization. We typically do 2 synchronizations a year with the EPSG database, matching its updates in spring and fall. We can import coordinate systems. I'm going to skip GeoCalc.dat for a minute. We can import from different types of files there, well-known text, PRJ files, GMLs. Those are just different file types that specify coordinate systems or coordinate transformations on the next line there, Esri format, GTF, Geographic Transformation File. Those are different ways to get some of those definitions in there from other places. These work simply en masse. If we're going to be bringing in a particular type of system here, I'll just go into a folder where I've actually got some PRJs. We just simply select a PRJ file and open that up, and brings them in. You can bring in one, as I just did, or you can actually mass import hundreds of those at once, and it will add those in, looking for any duplicates that it finds. It will give you a report on any of those things that you've brought in en masse as well. The geocalc.dat, I just want to mention this one very quickly. The geocalc.dat is actually a much older type of database that we used to use in the Geographic calculator. Back when I started here at Blue Marble about 10 years ago, that was the standard, but it has gone away in the current versions of the application. We've moved on to more robust XML-based data sources from the old, it was literally a comma delimited text file that we used to store custom parameters in. Some folks still have those around, but those are things that are sort of dying out as those very old versions of calculator are eventually being migrated up into to more modern versions of the calculator. That basically just allows you to bring in what we would consider in the software industry to be ancient definitions from old versions of the Geographic calculator. And down at the bottom, there are import and export options from XML, and the XML it's talking about is our own internal XML format that is used in the Geographic calculator. Now, if I wanted to share that custom definition with another user that I had just created, I would open up this dialog. It's going to show me categories of all of the different types of systems and geodetic objects we have in the database. I can go in here to our projected category, and it's going to open up the picker. There's at the very top level there, unfolded, there's my PRJ-based coordinate system that I just brought in. There's my SAMS folder entry that I just brought in there. I can come in here and select any of the projections that I'm working with. I can multi-select these if I want to grab more than one. I can just simply double-click on it, to return me back to the main list. And what this is going to do is build a list of things that you want to export. So if you have several coordinate systems or several of different types of objects, if it's coordinate systems and transformations or supporting definitions, so a coordinate system and an ellipsoid that you need for it, you can grab onto multiple things at once and build this list to export. And when we OK out of here, it's just simply going to ask you for a name of the file to write that out. I'm going to put this back out to my desktop, and I'm just going to call it Sam's Systems. And what that's going to do out on our desktop here, let me minimize my other applications. Out on the desktop, it's just going to give me what's called an XSP file, and that's basically an export file, a little shorthand there for us. We can give that to another user. It's going to be a pretty small file. It's only about 10K for the single definition that I did. It's a pretty compact format. We can stick it on a thumb drive, share it out on a network share, however you want to get that to somebody else. You can give that to them, and they can go under their data source menu and import that, and it will simply go into their library, and they then will have instant access to it. The final way to get these custom parameters out of here is in actually just simply sharing the entire database, the entire custom XML database. And we're going to find that under the Options menu, specifically in the Preferences. And in the Preferences, you're going to see different categories of those preferences, but you're going to see one called File Locations. And this is where we set the paths for defaults of everything in the application. So there's everything from our workspace, you'll see the data source chunk in here, and some other defaults for where we go looking for things. Now, to share out an entire custom XML file, all we need to do is make sure that we save that custom XML out to the shared network resource that we're going to put it on. Let's say it's a network drive. And then in the preferences, we'll simply go down to our network drives, and in my case, if I wanted to share it out to our own little internal folder where we have user backups or things like that, I could grab any one of those network locations and point my installation to use that common version of the custom XML. That's a very easy way to allow a lot of different users to access the same definitions. The only thing you want to make sure of is that if you want to have some extra protection on that, maybe lock down the sharing on that path so that not everybody has write access into that database. So those two bits there, exporting into the snippets or exporting out to the XML are really, using a shared version of the XML are really the best ways to get things out sort of en masse to share with another user. Once those are stored in your preferences, if you're going to share that database, that will be good to go every time you start up the application. When you go looking for coordinate systems or whatever type of object, you're going to be pointing to that common version of your custom XML if you're going all the way with the sharing there. So I think what we're going to do now is open it up for any remaining questions that have come in throughout the hour here. Heather, do we have any questions that we had during maybe that we didn't get to?
Yeah, is it better to share the whole custom XML file or just a few definitions?
Okay, so what I was just talking about there, whether it's better to use one or the other, this is really going to be sort of up to your use. So if I were the type of user that wanted to share a lot of coordinate systems, into the level of hundreds, if I were a large company, we have a very large collection of custom parameters, I would probably want to be using a common version of the database. It makes it a little bit easier just to administer rather than getting into all the exporting and the importing. makes it a little bit easier for, say, one administrative level user to do a lot of that maintenance that other folks will be digesting in their own local installations of the calculator. But as well, if you are, if you're just working with maybe a handful of coordinate systems that you want to share out, some folks have a lot of proprietary definitions, but then they only want to give some of their other users just a couple of them. Then exporting individually would probably be a better way to go. In short, I don't really have a perfect answer for that. There's no one size fits all. It's just a matter of how many that you want to be sharing, how often you're going to be administering the data source, that kind of stuff. If you have any particular questions about best practices, that kind of stuff, if you contact our tech support team, we can usually help point you in the right direction and make some recommendations based on exactly how you want your folks to be working with some of those custom definitions.
We also have a question from Russell. He wants to know why someone would create a custom definition.
Okay, that's a great question. Some folks never need to. So with all of the 5,000 some odd coordinate systems that I mentioned in the database, there's over 5,000 coordinate systems. There are over about 2,000 different transformations to get between different things. Even with all of those systems, the number of coordinate systems that are commonly in use in modern times has actually shrunk. There are a large number of historical coordinate systems from everything from absolutely ancient maps, very early surveys of particular countries. Sometimes the existing standards just simply don't fit a particular part of the world very well. Sometimes there's the need to have a standardized naming on a coordinate system that might have a different name, makes it a little bit less intuitive for folks to find. If you're perfectly happy using any of the custom projections that are in there, that's great. If you're the kind of person who's not able to find the thing you're looking for, either because it's not standardized or particularly for folks that are working in sometimes sensitive parts of the world, sometimes parts of the world that don't have a good geodetic control historically. Sometimes you're out there trying to reestablish a local geodetic control. It really has to do with a lot of the local need in many places. Cartographers, just to go a little bit farther afield, cartographers very often need to develop custom projections or custom parameters in standardized projections just to simply best suit an area of the world that they're trying to make a map in. So there's all sorts of reasons why you might need to make a custom set of parameters in there. But it depends on just simply whether or not you have something that isn't already in there, why you might need to do that. Okay, what else do we have? Heather, any more questions coming in?
Just related to the data source menu, what happens if a user gets locked out? It all goes gray.
Okay, for that, I'm actually going to hop back into the calculator for a second. So in the data source menu, when I clicked on mine, you'll notice it came right up, and I was able to get into any of these dialogues that I wanted to. I can pull that up, and I have instant write access into my database. The reason for that is that I am the local administrator for my installation. And that is going to be controlled under my administrative settings. And there's a couple of things here that can actually do that. Within the administrative settings, excuse me, I just need to get some of my GoToMeeting controls out of the way here so I can see my dialogues. Within the administrative settings, in particular, on the administrative tab, there is a lockdown setting. The application can be put into a lockdown by an administrative user. You're typically going to encounter this if you are working with a shared installation, so a network installation where you've actually got an administrator that is controlling folks' access. You'll notice in here there is a setting to lock the data source from editing. And if I put that in place, go back to my data source menu, you'll notice I can't actually click on anything in here. It's all grayed out. So that could be one reason that you're not able to get in there. And that would probably be the main reason why you wouldn't be able to make any edits in there. So if you see your lock the data source from editing setting is enabled, that's going to instantly block you out, and you may or may not be able to toggle that off, depending on if you are in a password protected lockdown from an administrative user at your company. If you are in that situation where you are locked out of the data source editor, and you are in lockdown and you don't know who your administrator is, we actually do. So for companies that are using this in that sort of network context, we actually maintain internally here a list of who the contact is for some of those security features. So if you need to be working with a custom set of parameters and you're unsure of who to contact at your company, get in touch with us, because we can actually put you in touch with the person at your company. That's a little bit rare. Most folks know who their local admin is, but if you don't, you can always ask us, and we can put you on to the right person who's actually maintaining your installation. Other cases where you might be locked out of that is if you are in a the word is escaping me here for a moment. If you are in an unlicensed state in the application, so if you don't have a valid license on there, that can sometimes lock you out from access. Looks like I actually just locked myself out again accidentally. That can gray this out and stop you from working with some of those features. So as long as you're licensed, and as long as you are not in administrative lockdown, chances are you're going to be able to get in there and work with some of those definitions. So great question there. Let's see here. I'll pop open the questions in GoToMeeting and see if we've got anybody else that we haven't gotten to. Let's see here. The question from Roy about importing coordinate systems in a comma delimited file or from Excel file. Chances are we're not going to be able to automatically bring in stuff like that. It's going to be typically in a fairly unstructured format. The only odd example of that where we would probably be able to automatically bring those in would be if the comma delimited file does actually happen to be one of our own formats. There are a lot of sort of non-standard ways that other software packages have stored those in the past. If you do have files like that you're trying to get in, sometimes it depends a little bit what you mean by the type of comma delimited file. If it's something like a what's called a well-known text file, we can definitely read those. Those are actually comma separated inside, but that might not be what you're talking about. If you've got a particular source that you're trying to bring in here, definitely get in touch with us at the support department, and we can do our best to point you in the right direction with your question. Let's see here. There's a question from a user of Global Mapper, actually, and tying the two applications together. Recently, in version 15 of Global Mapper, which is our desktop GIS software, we did add the ability to hook Global Mapper up to the Geographic calculator. The two applications can communicate back and forth with each other, and the gentleman's question looks like he's actually left the session. I'll answer it anyway because it's a good question. The gentleman's question is, what's the benefit of tying these two together? And that is that it provides both a validation or a double check, but in a lot of cases, the built-in database that was found in Global Mapper is a much more limited set of coordinate systems. If you define custom parameters in the Geographic calculator, they are available both in the calculator and over in Global Mapper, so you only have to maintain those projections in one place. If you do link the two together and switch on the GeoCalc mode in Global Mapper, it gives you basically just one place to administer those projections for both of the applications. And it looks like the last question that we have is, how would we manage station velocity and the epoch of a coordinate? And that is relating to a particular type of custom definition that we have in here. I'm going to take a look under the coordinate transformation definitions. This is a little bit different than what we've done. We have recently, in the last year, added support for spatial transformations that have a temporal component. So what I'm going to do here is just point you in the direction to get started with this for velocities of transformations. If I don't go far enough with my answer here, please follow up with us, and we'll do what we can to get you the information. So I'm going to start by just creating a custom coordinate transformation, and I'm going to skip right over to the definition in here. Down under the method, first of all, what we've got is the source and target. These are going to be what coordinate systems we're going to be transforming between. Down in the oops, excuse me, I am not in the right dialog. I'm going to actually back out of here, and I'm going to go under datum transformations, which is where I really meant to be. I'm going to create a new datum transformation. And the source and target are going to be the datums we're starting on and the datum we're ending on. And you're going to find in the methods list, you're going to see in the methods list, there is going to be a time-dependent Helmert transformation. The time-dependent Helmert is a 14-parameter transformation. So that is, it is essentially a 7-parameter transformation with velocities for each of those axes. So time-dependent Helmert is the method you're going to be looking for there. You can fill out all of those 14 parameters for the velocities. If you have any questions about which of the variables in there is which, if you are coming from a particular publication, I'm going to steer you to our support team to fill that out, but this does allow you to deal with the velocities, the change velocities in those transformations between two different reference frames. Once you've selected two particular coordinate systems, if you have a date for the data, so the epoch of the data, that is going to be found right on the coordinate system control. I'll show you that in just a second. There is also an HTDP converter. That is a specific kit that is published by the National Geodetic Survey here in the States. It is useful for temporal transformations only in the North American region. Time-dependent Helmert is a standard transformation that you can apply anywhere on the planet. So I'm going to point you in those directions, and then I will just show one last thing here. You'll notice on the date controls here on the coordinate system controls for input and output, there is a date where you can apply the epoch of your data. And by applying an epoch for input and output, that is what actually allows it to calculate the temporal portion of the shift, to do the math with the velocities that are a part of the transformation, to allow us to actually get the last little bit there, which is the temporal part of the shift for the spatial shift between two systems. So I may not have gone all the way with the question you're asking. If you do have more clarification you're looking for, please feel free to drop us an email at the geohelp@bluemarblegeo.com, and we can follow up with any of the other bits that you're trying to get to with that question. Looks like we've wrapped up all the questions for today. So what we'll wrap up with is our next month's session is one too far there. Our next session this month is going to be an introduction session getting started with Global Mapper. Today's session is being recorded. We will have that hopefully processed and posted on our previously recorded webinars website for viewing hopefully early next week. Again, tune in for our next session for Global Mapper coming up on February 20th, and as well our next calculator session next month. We'll be going over the new features coming out in the new edition of Calculator, which is going to be Geographic Calculator 2014. Thanks everyone for tuning in today, and we'll see you next time.
Thanks everyone.